hello everyone. Today we're going to be, are the lights supposed to be on? That's fine, yeah. All right, my name is Kevin. Unfortunately, Albert couldn't make it, so I'll be soloing this for today. But today we'll be going over Git and GitHub, which are two very important tools that you're going to be using a lot throughout Web Lab and beyond in like just general CS stuff. So, well, what is Git? Git is a version control system, and that probably doesn't mean a lot. So what is a version control system? So version control is basically the practice of tracking changes and managing a code base. And at first, this might sound kind of simple. Why do we need a specialized system just to like track changes? Well, to find out, let's consider the following example. Here we have Ben, and Ben has a nice little document. Let's say Ben has a friend named Alice. Alice says, wow, it's a pretty cool document. Can I add to it? And, oh, please. Okay, yeah, so Ben emails the document to Alice. She makes her changes, sends it back. And this sounds like a pretty good system, right? Like you can just like exchange messages with someone, keep track of changes that way. But then let's say now this is a programming project. It's basically no different, right? Except maybe there are a few more files on both sides. And you can kind of easily see how this can quickly get very messy, sending messages back and forth, telling people where to change things. So in this example, what could possibly go wrong? So the first issue that we're looking at is the synchronization of files. And it's hard to keep files synchronized manually this way. There's lots to keep track of. Let's look at this example again with Ben and Alice. So let's say Ben finds a bug in line 3 of some file. Only he knows about this bug right now. Alice is just chilling. Alice says, okay, everything looks good to me. She doesn't find the bug, and she submits the website as is. And now the team is sad because they submitted a buggy website. There wasn't any automatic system to help them keep track of changes. There wasn't enough communication between them to do it manually. Things are just going wrong everywhere. And so the problem with the synchronization of files is that no one knows which file is the most updated at any time. So the second issue we'll be looking at is the collaboration between team members in a code base. So back to Ben and Alice. So Ben finds the issue that there's another bug. While Alice is looking at the formatting of the code, she thinks it sucks. So Ben makes his changes, Alice makes her changes, and their code is now different. And so between themselves, they're talking. Ben is like, okay, I know you made these changes here. I made these changes here. Can you copy them over one by one? Obviously, no one wants to do that. It takes forever. It sucks. And so we have encountered another problem here. If there are two versions of the same file, and both of them have changes in different places, then how do we know how to join the files? And even if we did know how to join the files, how do we do it in a way that doesn't take forever and prone to error? So the third issue we'll be looking at is version history. So let's say Ben is working on this coding project. He makes some edits, takes out a few lines, add a few lines, and then a few hours later, or an hour later, I guess, he realizes those lines he deleted were actually important, but they're gone forever now. There's no version history, and so if we break something, then can't go back and recover it. So with these three issues in mind, oh, please change size. Okay, so how do we solve these problems? So what if we use a familiar system like Google Docs? It sounds like it could be pretty good for this, right? Takes care of the synchronization and merging issues. I mean, if you've used Google Docs, you know that like it basically does these things. It keeps the version history. You can always undo, redo, go and look at the edit history. But the problem is, usually you don't want real-time collaboration for these types of projects. For various reasons that we'll see. Like, for example, what if you're developing different things simultaneously? It gets very hard to manage. There's just like text moving around everywhere. If it's real time, it's very hard to keep track of your own stuff. And let's say like maybe two people are working on two different versions of the same feature. Then how do you have them collaborate without like editing the same thing at the same time? So we want to be able to work locally and then later on merge changes when you're done with a particular part. So the way that we actually solve these issues is a system called Git. And what does Git do? So Git actually tracks the changes in your code base. And how does it do that? It uses math. So let's say we have this document called my doc, and it has a short story on it. So you see these 3 lines. And then we make an edit to it. We add a 4th line. It says like corgis. So you have a difference between version 1 and version 2. And then we decide to take out the 3rd line. So we see that between these 3 versions, we have a certain set of edits. And so that is the math. So in between version 1 and version 2, you add a line. In between version 2 and version 3, you subtract a line. So by keeping track of these sets of adding and subtracting lines, Git is able to track your like the state of the code base by just taking the initial version of the document and then applying all those edits, and that takes you to the final version of the document. So in Git terminology, the repository is your code. It's just the set of files that you're tracking. In this case, for WebLab, it'll be your website. A commit is the set of changes that takes you from one version to the next version. And so that is the math. And the log is the set of commits for each version. So basically, this is the commit history. It's just tracking what changes you're applying at every step. So that's the commit history. And so what issues does this tackle already? So just based on this model alone, we already solved the version history issue. With our log, we're keeping track of every single commit. So we easily have the history. And this allows us to go back, look at what changes we've made and revert to it if we need to. So that's one problem down. So what about the other 2 problems then? To solve these, we have to look to some more advanced features. So Git servers. So Git servers are a centralized way to have people communicating on a code base. So how does this work? So back to Ben. So he makes some edits, and then those edits are packaged in a commit. So it's like one unit of like a set of changes. And so when you're done with those edits and you want them to be like synced across to other members of the team, Ben pushes those commits to the Git server. And so the Git server tracks those. And so when other members of the team are like, okay, I want the most updated version of the file, they pull from the Git server into their own code base, and it's reflected in their code. And so now Ben and whatever other member of the team, they have the same versions of their files. And the Git server is like the middleman between that, like moderating all of this. So far we have these terms. A commit is a set of changes. A push is sending commits from your like local copy to the Git server. And a pull is taking the copies on the Git server and then putting it into your local copy. So how do we actually merge the files though? So we have same setup. So let's say Alice here makes some edits on her code. She pushes it to the Git server. Ben has his own set of edits in the same code. So he can't push. The Git server recognizes that his version of the code is different from the version in the server. If everyone is pushing like simultaneously, then we have the same problems we started with, like you just don't know which changes to use. So instead, Ben has to pull first, get the most updated version of the code, and then merge it with his own code, and then he can send it back. And so now the Git server has the best of both worlds. It has Ben's edit and Alice's edits combined in a way that's effective for everyone. So this solves the synchronization issue. So pushing commits to a Git server allows it to keep it as like a centralized one source of truth. So the Git server will always be like the most updated version, the version that you're pulling from. There's no need to like go back and forth between individual team members and find out like what do we need. Yeah. So by pulling the collaborators changes before you do it on your own, you always ensure that you aren't overwriting other people's stuff because you're getting all of their changes first, then figuring out how to apply your own, and then sending it back. So what actually happens during a merge though? So we kind of abstracted that away. Let's actually look into what happens. So back to my doc. So on the left, we have Ben's local version. On the right, we have the version in the Git server. As you can see, there is a single difference. It's just the fourth line. So in this case, if Ben pulls, Git simply just applies that fourth line. There's no conflicts. It's pretty simple. It's just adding that one change. Let's say we have another scenario though. Say that Ben has a fourth line that says, I love cats, while the Git version says, like corgis. So we can't simply do what we did before. You can't just overwrite the local version with the Git version. That messes up a lot of things. So this is what we call a merge conflict. And in this case, Git will actually tell you, please merge it manually. And so Ben pulls, merges it manually, and then he can send it back to the Git server where the change is updated. And so when there's a merge conflict, the process stops being automated. If you think about it, it kind of makes sense. You know, if another teammate has conflicting code with you, then the best option is to communicate with them. Okay, how do we combine our code in a way that's like reflective of what our code base is supposed to do? So you have to have manual communication when there's a conflict. And then once that's resolved, then you can push back to the Git server and then everyone is happy. That version of the server is the one that everyone should be using. It's agreed upon. So this solves the collaboration aspect. So Git uses an algorithm to merge files based on your commits. And then if there is a conflict, if things go wrong, then you fall back on manual intervention and communicate with your team members. Okay, how do we solve this merge conflict? What is our code actually supposed to do? And then figure it out from there. Woohoo, we solved all of our problems. This is great. But how do we actually use it? So Git sounds great and all, but how do we actually use it in our own code bases? So to find that out, we have to learn about the command line first. So the command line is sort of the secret menu of the computer. I don't know how many people are from California. This is In and Out. So how In and Out works is they have like a regular menu that's very plain, but there's like a bunch of other things that you can order behind the scenes, but you kind of gotta like know what it is. I'm sure this has entered like general popular culture by now, but yes. So the terminal or the command line is a computer secret menu. It's kind of like that. So most people are probably familiar with navigating through your computer graphically. So like clicking on files, folders, things like that, it pops up on your screen. The terminal is, or the command line, sorry, is basically a way to do that, but with extra features as well. It's no longer graphical. It uses text, but it's basically the same thing. It's just a way of interacting with your computer and its file system. So before we really dive into it, this is some basic terminology for using the command line. So the file is a file. That really doesn't change. It's just a basic unit of storing information on your computer. A directory is essentially a folder which you can use to hold files or other directories. And the terminal is the window that you access the command line on. As you can see, I have already messed up using it as a synonym for command line. I'll probably keep doing that, but yes. In the command line itself, there are some very useful shorthand symbols. So the 1 symbol is used for current directory. So I'll be using those interchangeably. 2 is parent directory. So that's the folder containing the folder that you're currently in. And that squiggly symbol, the tilde, sorry, is shorthand for home directory. And so this is just some directory that by convention, your computer has designated as home. So we'll do a little demo to explore the command line. Okay, so this is what the terminal looks like when you open it up. There's a couple, like how you open it up varies from operating system to operating system. How this exactly looks also varies from operating system to operating system. We'll give you more information on that later, but essentially they all look something like this. So you have this text area where you enter your commands, and then it's like a feed of just commands and stuff that goes down. So let's see what this text here shows. So let's say that you're like dropped in an unfamiliar scenario, a logical first question you might ask is, who am I? So in this case, it shows you who you are in like the very left of your terminal. Right here, it's showing my username and my workstation. The @ symbol is just like a delimiter. So once you have this information, a logical second question might be, where am I? And so we learn our first terminal command to figure that out. So pwd stands for print working directory. It essentially tells you where your terminal is currently positioned in the operating system, in the file system. Most terminals also show you where you are directly after your name. So this is really useful. It tells you who you are and where you are at all times. And just as a reminder, the squiggly symbol is short for home. So that's equivalent to home/ks. So that's cool and all. We figured out who we are, where we are, but that's not all we want. We want to actually be able to interact with the file system. And to do that, we'll learn our first other command that modifies the file system. So that's mkdir or make directory. A lot of the terminal commands are like shorthand for words, so it makes it easier to remember. So make directory essentially is what it sounds like. It creates a directory in the current folder that you're located in. And so in this case, you can see that we made this directory called WebLab. Yeah. So now we have a new directory, but can we actually do anything with it? Well, it turns out we can, and we learned this new command to interact with it. So cd stands for change directory. This is basically telling the command line to move somewhere. In this case, we're moving into the WebLab directory. And so you can see that after the colon in the terminal, the folder that we're now in says WebLab in that blue bolded text. So yeah, and then if we print the working directory, we can see that it's now WebLab. Cool. So let's clear out the terminal a little bit. So the clear command is just a useful thing to clean out the edit history of the terminal. So we continue. So that's great and all. We have directories now. We can move into them, we can create them, but directories don't do everything on a computer. We actually have to have some way of manipulating information. And so we need to be able to create files. So this is where the command touch comes in. Touch is, you can think of it sort of like the magic touch. You're in a directory, you use the magic touch, tap someplace in the directory, and it creates whatever file you want it to. In this case, we're creating a file called file.js. And cool, now like we have a file. Or do we? How do we actually know that this file exists? As you can see, like a lot of the commands we've been doing, they don't give you any like response. You just like run them, and then pray that like they worked, you don't get any feedback. So how do we know that we actually have this file? How do we know that we have anything? That's where the ls command comes in. So ls stands for list. It does exactly what it says. It lists whatever is in your current directory. So you see that if we run ls here, it shows us that file.js is indeed in the web lab directory. So this gives us a way of so now we can not only interact with the operating system by creating things, by moving through it, we can also view it. And if you this is just demo, if you create another file and you run ls again, we can see that both files are indeed there. Cool. All right. And then one convenient thing is that if you have directories and you run ls, most terminals will conveniently highlight the directories in some different way. So right in this case, it's bolded and blue, so you can easily differentiate between files and directories, because there's no in a graphical representation, you would see a file icon and then a folder icon, and it would be different. In a terminal, you can't really see that, so they use different flavors of text instead. Cool. So we have creating files, we have creating directories, we have moving, and then we have viewing things. So those are most of our basic functions. But let's say we have some file full of text. File.js is full of some website code. And what if we actually wanted it to be in this new directory? It's really a pain to have to create a new file and write everything again, copy paste it manually, things like that. So we have a command that makes it simple. So mv stands for move. If you look at the line there, it's mv, and then you can give it a source name and a destination name. In this case, we're moving file.js to our new directory. And you run that, and if we run ls, we see that file.js is no longer in the web lab directory. If we run ls on the new directory, we can see that file.js is indeed in there. Cool. All right. So what happens though if we run mv on a file? So we give it file2.js as a source. What if we give it a destination name that doesn't currently exist? That's not the name of an existing directory or the name of anything that already exists. Does anyone have any guesses as to what might happen? No? Okay. So what actually happens is you can see that it moves it from the current directory back into the current directory, but with a different name. And so this is actually just a simple rename operation. So yeah, you can do, this just kind of shows how you can do a lot of operations that you're familiar with using simpler operations as a building block. So in this case, we don't need a specialized rename operation. You can simply move it from the current place back into its own place, but with a different name. And it does the same thing. So even though terminal commands seem kind of confusing and complicated at first, you can kind of put them together in neat ways to do a lot of things that you're used to doing. Okay, cool. So in the similar vein, we have the cp command. Cp stands for copy. You give it a source file and a destination, and it basically copies that file exactly with a different name. So it's another way of doing the same thing. So this is just for copying. And if you run ls, you can see that indeed there is a copy of that file. Cool. So let's say that we actually didn't need all of those files. So we went ahead and created a bunch of files and directories, but it turns out that was all wrong. We don't need any of it. We actually need this storage space for something else. What do? We have to do some cleanup. So the rm command stands for remove. It's exactly what it sounds like. You give it a list of files, or you give it a list of files that you want to remove. And so if you see the command, it's rm and one file name and another file name. And then if you, after we run that, we run ls and we see that file2 blah and file2 meh are gone. So it does exactly what it says. But what about directories? So for directories, we have this rm directory command. It's exactly the same thing, except you use it to remove directories. But we can see that when we try to remove the new directory, we still had that file.js in it. It doesn't let us remove directories that have things in it. So what do we do? Does anyone have some commands they think will solve this problem? Maybe a first step? Yes. Yeah. After that, what would we do? So once we move into a new directory, what's the next step? Yeah. Yeah, so we remove the contents of the file, and then, so the folder is now empty. What would we do after that? All right, for the sake of time, I'm just gonna go. Yeah, so that's basically it. So we go into the new directory using cd. We remove the files inside the directory using rm. And then we cd out of the current directory. To delete the current directory, we have to be in its parent and then delete it. So the double dots represents your parent directory. You can use cd ... to go back into your parent. And then you use rm directory to remove that directory. And now we run ls and we can see that the web-left folder is empty. So yeah. So I know there's a lot. These slides will be up, so you can go back and review it, and you can also just play around in your terminals to like get familiar with the commands. But a quick recap of the commands we learned so far. First is pwd, which is print working directory. Basically tells you where is your terminal currently at. ls stands for list. It lists the files in your current directory. cd stands for change directory. You give it a directory name and you jump into that file folder that you specify. Make directory, you give it a name and it creates a folder with that name. mv, you give it a source and a destination. It moves something from the source to a destination. cp, give it a source and a destination. It copies something from that source to destination. rm removes a file, and rm directory removes a directory. And most of the names kind of give you an idea of what the commands do. So yeah. Cool. So now that we use the terminal, you basically know how to use Git, more or less. So you actually use Git through the terminal. It has its own set of commands, but it's sort of applied in the same way as we just saw. There's just other like words that you use, I guess. So we have this terminal. This is Albert, so it looks a little bit different from mine, but it basically has the same thing. So the blue text on the left, like the one that says test and one that test, that's the text that says what your current directory is. And then the white text is basically like the commands that you're running. So at first, Albert makes a new directory called weblab test. He cds into that directory. And you can see that the blue text is updated to weblab test. So he creates a new file called index.html. And then to turn this folder from a normal folder into a Git repository, you have to run our first Git command here, git init. And so this initializes a empty Git repository based on that folder that you're currently in. And so now you can see that there's this dark blue and this red text. So this actually is the like Git information on the terminal. So just like we have the current directory in that light blue text, in the dark blue and the red text, we have the current Git repository. Cool. So the next Git command we'll learn is git status. It's exactly what it sounds like. It tells you the status of the Git repository you're in. And we can see that we just created a file. Nothing's happened yet. So it tells us no commits. There are no changes so far. The other information below that, the untracked files, just tells you that, let's see. Okay, the untracked files just tells you that there are files that Git is not looking at yet. So it hasn't been like added to Git's commits yet. So basically, how is this? Okay, so when you're using Git, there's actually 2 stages to like making changes. Git doesn't want to have to track every single one of your changes in real time. This takes a lot of resources. This is inconvenient. And not every single one of your changes might be like good. You might have like typos, things like that. So tracking all of them real time would be really painful for everyone involved. And so instead, there are 2 sort of stages to telling Git that you want to make an edit. So once you're actually typing on your terminal or on your computer, you make some edits to a file and you're like, okay, this is good. So you run git add, which it says right there, use git add to track. You run git add to tell Git that this state of the files is good. Like I want to add it to the current commits. And so once you add like all the files that you've edited, then Git like knows, okay, I have this set of edits. It's like all coming together now. Like it's tracking those changes that you're telling it to track. And then once you've decided, okay, this set of changes is good, I want to package them into one package so I can send them to like the Git server. Then you run git commit and tell them everything that I've added, that's good, you can take it now. And so that's why like we have 2 different commands to tell Git what to look at. We don't want to be tracking those in real time, so you have like 2 different states. And so right now we have an untracked file, which is the index.html, I believe. So we created the Git repository. That's the first file that we made in the previous slide. And so we haven't told Git to track that file yet. We haven't added it yet. So it's just telling us there's still edits here that it seems like you're in the progress of making. Tell me when you actually want me to track it. Cool. And so we decided, okay, index.html is good. We tell Git add index.html to the set of like good things. So we're done with index.html. And so now we run git status. It tells us still no commits, but we do have a new file now that Git is tracking. You can see in the green, it's index.html, and it's awaiting a commit. So Git is telling us, I'm looking at this file right now. Tell me when you think it's ready to be sent to the server. And so we decide, okay, it's good. So we run git commit. The -m just tells Git that we want to include a message with this commit. This is always like good practice because you want to be able to like look through your commits and see like, okay, this is the reason I made that commit. This is the reason I made this other commit, and differentiate between them. So we commit the added files using this commit message, OMG, I made my first Git commit. And then Git will tell us, okay, this file has been added. There's a bunch of like status stuff that we don't really need to pay attention to, but the main things are the commit message there. It tells us there's one file that's been changed, 0 insertions, 0 deletions. So that's the math that it's tracking. And then it tells us we've created a file called index.html. And so now with this commit, we sort of package the changes that we've made into one package that can be sent up to the Git server. And so the cool thing about Git is that with a system like this, you can add files that you want to be like sent to the Git server, but still make changes on other places that you don't want other people to like see yet, I guess. So you don't have to have your entire code base be fully updated every single time you want to send things to the Git server. You can pick and choose, like, this is good, this is not good. Take only that good part and then send it to other people so they can like have, and then you can keep on developing your other things. Cool. And so we run git status again, and it tells us, okay, we've committed everything. There's nothing else to commit. Working tree cleans just means that like everything's good, basically. So now, remember back then we had this whole version history thing. We need to be able to see our changes, not just make them. So that's what this git log command does. It basically just shows you the log of commits, and you can see right there, Albert has made this commit that says OMG, I made my first git commit. And so once you have more commits, it'll show you the log of everything. So you can go and look through them. You can open each one up and see what changes you made. And Git also offers the option to revert easily. So you can just tell it, okay, I want to go back to this certain commit, and it'll just revert the files back to that version. So that's cool and all. We have Git set up, but remember that one of the central benefits of Git is that it's centralized. It has a server that keeps all this information. So we actually need to find a server to hold all this stuff. We need a space to hold all our information. And so that's where GitHub comes in. So while Git is like the system that makes like the system that holds all this together, like the command line information that we just accessed, that's Git. GitHub is the actual server that stores all that information. And just for clarification, Git and GitHub are like not the same thing. Like they're not owned by the same people. They're two completely different things. But yeah, GitHub is what we use to actually hold those changes. So you go to like github.com, I think, yeah. github.com takes you to GitHub, and you can like create an account, set up your like own basically space to hold your things. Yeah. So once you create an account, you can go into their settings thing. This is Albert's account. You see that it shows you like a bunch of your current projects. So Git is basically a way of holding all that information. If you look in that red text or that red square in the corner, you press new repository to, well, create a new repository. And so what this does basically, it just tells Git, okay, I want to have this space in the server stored for this certain project. And you give it a name, web lab test, and then you can go ahead and create it. Cool. So now that we've created a space in the GitHub servers, how do we actually link that to the Git that we're just messing around with in the terminal? That's where all this stuff comes in. So basically, GitHub wants to make this as easy as possible for you. It just basically tells you, if you want to set it up, you can just copy paste these lines. And so that red square just tells you, if you have existing repository on the command line, so you created your GitHub or Git repository like we just did, you can use these commands and it'll automatically just do it for you. And just to break down these commands, so git remote, blah, 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 basically just tells you, this is the URL of the server that I want to use. And it kind of makes sense, you know, the remote part is like, that's like the remote repository that I want to like link to my local repository. And then the other stuff, the git branch and git push basically just tells you, take the changes that I have on my current repository and send it to the remote repository. So it's like, first you link the two together, then you take whatever you have on your local one, then you send it to the server. And so now the server is updated. So we go back to our command line, put in those files, put in these like commands one by one. It will tell you some like status information. And then if we go and refresh our GitHub page, it'll show your new repository. And so that's index HTML file that we made. Cool. So now we have a Git repository. It's on your local copy, it's on the server. Because it's on the server, now that means we can use it for the reason we have this in the first place. We can collaborate with other people. They can also access these files and make changes to them. So now we're going to walk through solving a merge conflict. So let's say we go to sleep, and a day later, somebody else starts a day later, you go into your index.html and you start writing this code. All is well. You look at the status, everything is fine, everything's up to date. You have some changes that you haven't tracked yet. That's just what we just put in index.html. So you add it using Git, and it tells you, and then you commit it. So wow, you have a website now. Tells you, okay, this is the thing that you just did. You change one file, you have 2 insertions. You told me these changes are ready to go. I'm ready to send it to a server. And so once you actually try to push it, it tells you something. Something's wrong here. It looks like someone else has already made edits to it. So you can't just go ahead and push it directly. And so this is the merge conflict that we talked about earlier. So you go onto GitHub and you look, somebody made some edits, and the code in this Git server is now different from what you have locally. Cool. So in this case, what you do is you first have to pull from the server. So pulling is telling Git to take whatever is in GitHub and try to send it to my computer, and so we have the most updated version of the file. So we try to do that, and then it tells us it's failed. It can't actually pull from the server because there is a conflict. So somebody made edits in the exact same place that you made edits. And it says right there, there's a merge conflict in index.html, and it tells you, do it yourself. Figure it out between you and your teammates, and then come back to me, and then we'll merge it then. So we open up the file, and then most modern code editors will conveniently tell you, they have integration with Git, so they'll tell you the top is the current version of the file that you have locally, and then the highlighted in blue is the version of the file that's existing in the Git server. So it'll lay them out side by side, so you can decide which one you want to keep and which one you get rid of. And so once we have this, we can figure out what to do from here. So you have a couple of options. One is to overwrite your local stuff. So that's telling Git, okay, whatever the other person has is better, get rid of mine. You can overwrite the stuff that's coming in, which tells Git that their stuff is trash, keep mine instead. Or you can go ahead and sort it out by yourself, okay, keep these lines, delete these other lines. We'll combine both of our changes in a way that satisfies everyone. So in this case, we're just gonna go ahead and, so this is just the difference between the 2 commits. In this case, we combine the 2. And so now, once we've gone in and made those edits manually, we can tell Git, all right, we want to merge the things. And so now it works. So we've taken the information that's coming in and then combined it with the information that's in our own copy, and then Git is happy now. There's no more conflict. So you can add index.html. Git tells you, okay, everything's working out. Index.html is waiting to be committed. Tell me when it's ready. You commit it. Usually you want to have some informative text. So telling Git, okay, this is where I fixed the merge conflict. Yeah, and I guess it's key to note that the other people also see the exact same commit messages. So this is also a really great way of communicating with your team members of what's being done and when. So you're telling your other team member, okay, I fixed this conflict. You don't have to take care of it anymore. And so then you push and it works. Git tells you that you successfully pushed your copy to the server. So now we look at the log. So how the log works is the most recent stuff is at the top. So at the very bottom there is when we first made the first commit, just creating index.html. And then somewhere else, somebody else made a commit. And so that's the second one. And then the third commit is when we tried to make our own local changes to index.html, and then it told us there's something wrong. And so the fourth commit is just fixing that conflict. And so with this log, we can see exactly what happened. And then if needed, we can go back to any like previous version. Like let's say in the merge conflict, when we fixed it, we actually made a typo. And so it broke the entire website. So we want to go back and use like the original commit we had before we started like combining the two different versions. And this will probably come up a lot. You know, merge conflicts are kind of hard to fix. So when you're going through and like combining them manually, sometimes you'll make a mistake or two. So it's really nice to be able to step back and restart that merge and then like fix it. Cool. And then we look in GitHub. It's also been updated as well. So one last thing. So now that you know sort of the basics of how Git works, we actually have a workshop today that will use these exact like techniques. So you will need to get the workshop onto your own laptop. So the link is there, weblab.2/capbook. How cloning the repository works is you open your command line, you hit the like button, the green button there, sorry. The green button there, and it gives you like some URL that you can use with your Git like terminal to get that file onto your computer. We'll also send out more information on this. And if any questions come up, please ask us because this can be confusing. Yeah, so quick recap. So we went over the terminal. So basic commands you can use to manipulate the operating system. We went over Git, which is the system that we use to sort of manage changes across the code base. And we went over GitHub. Okay, this is just, yeah. So this actually tells you everything you need to know, mostly, for actually using Git. We also have cheat sheets. So cheat sheets, basically, it has like, we have like, I think one for every topic, basically. You can use those and they basically have all the information that you need if you want like some handy reference as you're like typing in your terminal. Yeah, cool. And then we have lunch right now. Yes. After lunch, please be back at 1 p.m. We'll be doing HTML and CSS with Tan, and yeah.